Over my shoulder you'll see two funnels. These sit above the boiler rooms of HMS Belfast. Today we're going to be looking at the main machinery, capable of driving the ship up to about 32.5 knots full power, or at economical steaming, taking it about 8,500 miles. So let's now go and look at the boiler room, which is situated below the waterline of the ship. So here we are in the forward of two boiler rooms on HMS Belfast. The crew in the boiler room would have been a PO in charge, one or two leading MEMs, plus two or three mechanics to look after the rest of the auxiliaries in here. Because air is being drawn straight from outside and accelerated through the forced draft blowers to create a positive pressure in here, conditions could be pretty grim. In the tropics, quite pleasant because you've got a good airflow, but of course up in the Arctic Circle you have got temperatures outside of minus 20, 30. It could be a lot colder down here when the air's been accelerated and whistling past you to supply the boilers.
Never was so much gear put into so little space as in an engine room. Pumps, steam pipes, valves, dials, turbines, and still more pumps.
Each boiler room contains two Admiralty 3-drum boilers, like the one behind me here. And these are constructed of 3 drums. At the top, there's a steam drum. At the bottom, 2 water drums, one either side. And these are connected by a series of pipes, some of which go on the outside where water goes down to the water drums, and the others through the furnace where the heat is transferred and turns the water into steam. Some of it is tapped off and used around the ship. The rest of it goes into the 2 big manifolds halfway up the boiler there, and then goes back through the furnace where it becomes superheated at about 400 psi and 750 degrees F. To get the heat, furnace fuel oil is burnt by pumping it in under high pressure through these sprayers, and the air is directed around the outside to complete combustion. To ensure that the fuel is being burnt efficiently, there are periscopes fitted in the uptakes to ensure that the funnel gases are clear.
What were your fears on board the destroyers with regard to the superheated steam?
Well, I mean, especially if you were in action, if a pipe was superheating, steam got fractured, well, it just chop your head or anything off. It was invisible, you know, you couldn't see it. If you had an escape, that was it.
It would literally cut you in half.
It would literally cut you in half, yeah. Because I recollect it was very noisy in the engine rooms, but if somebody whistled, you heard it, and this was one of the things that was taboo in boiler rooms and engine rooms for anybody to whistle, because that was a sound of escaping steam.
Of course, with all the machinery running down here, this is a really noisy space. The forced draft blowers at the top supplying the air ran at about 17,000 revs and gave off a high-pitched scream. The rest of the machinery, the fuel pumps, the generators, were more of a low rumble, but still pretty unpleasant. And of course, in the early days of HMS Belfast, air defenders wouldn't have been worn down here. So when the ship was at action, like the engagements of the Battle of North Cape, the crews down here really wouldn't have been aware of what was going on. They would know they were going into battle, but they wouldn't know anything unless they actually took a direct hit and had to react to it. And that's to maintain power to the engines and keep all the machinery running as well as possible.
Our duty was to pursue the Scharnhorst at maximum speed. The Scharnhorst was faster, so Belfast had to go as fast as it possibly could. We maintained full power for, as far as I remember, 17 hours. Now that's like driving a motor car around a racetrack with your foot hard down on the pedal for 17 hours.
During this situation, was the watch system still in place?
No, we were at action stations. Everybody was on duty for that length of time.
What was the atmosphere like?
Tense, because you knew that when we got near enough to the enemy we were going to fire.
So here we are in the forward engine room of the ship at the manoeuvring platform for the port outer engine. In front of me are 3 hand wheels. There's the ahead throttle valve, a stern throttle valve for manoeuvring, and a cruising turbine throttle valve. The ahead throttle directs steam to the high pressure and then the low pressure turbines to drive the ship up to about 32 knots. The astern turbine is used for manoeuvring and going astern, and for economical steaming, when you really want to extend the range of the ship, the cruising turbine can be used. Behind me here is the telegraph, so engine orders would come through this from the bridge via the primary steering position to all of the manoeuvring positions for the 4 engines on the ship. So here we are standing in front of the port outer engine. Whichever route the steam has gone through the engines, it all ends up in a condenser which is slung underneath the engine itself.
You see, the water used to start in the sea and it would finish up in a person's stomach. You could drink it, and it was good pure water, and it was even purer water for the boilers, because if you got some salt water gone into the boiler water, then you'd have to change tanks immediately. Yeah, it was a very technical thing. Then you went onto the engine room and you found out how the steam that you'd just produced used to enter the engines and then turn the turbines. The steam would then drop down underneath the engine where it was turned back to water. So it was always a recycling job.
So this is the starboard outer engine, and what we're looking at here is the cruising turbine. Small turbine used for economical steaming, generates about 5,000 shaft horsepower. When it's clutched in and in use, it drives the whole of the rest of the engine, plus of course the propeller. It drives through its own primary gearbox, through a damper and a clutch and a flexible coupling onto the high pressure turbine. When the high pressure turbine is in use, the cruising turbine is clutched out, steam goes through all the stages of the high pressure turbine, losing a little bit of energy at each stage. When it goes through the last stage of the high pressure turbine, it goes through a pipe into the low pressure turbine and through all the stages in there before being condensed in the condenser underneath the engine. So when we look in here, we'll see the final stage of the low pressure turbine and the final stage of the astern turbine. So whichever route the steam has taken, whether it be ahead or astern, it comes into this chamber and goes down into the condenser where it's turned back into feed water. So what we're looking at here is the main gearbox for the starboard outer engine, with the high pressure and low pressure shafts driving into it. They go through a single reduction double helical gearbox which drives the propeller shaft and drives the propellers further down the ship. Each engine develops about 20,000 shaft horsepower, which will take the ship up to 32 knots. Of course, the downside of this is that the boilers are burning about 26 tonnes an hour of fuel.
From what you've said, there doesn't appear to have been any celebration when the Scharnhorst was sunk.
And not in my engine room. Relief. But I don't recall anybody actually cheering or waving their arms. I was so overcome with pity. First, a declaration over the loudspeaker. We have sunk the Scharnhorst. That down the ventilation tanks came the smell of oil fuel. Now, the Scharnhorst discharged hundreds of tons of fuel, and it took no imagination that if they were survivors, they were swimming in oil fuel. I don't think I felt like cheering. The job had been accomplished.
In 1939, HMS Belfast triggered a magnetic mine in the Firth of Forth, causing extensive damage. In the report, one of the factors mentioned was that the engines had leapt off their mounts. Just to give you some idea, this is the sliding mount for this turbine, and these are the sort of things that would have broken free when the ship triggered that mine. The ship underwent a large refit afterwards, with repairs lasting about 3 years, and very little change was made to the engine or boiler rooms.